You are moving right now, and not just around the sun, not just around the Milky Way. Our entire galaxy, along with thousands of others, is drifting through space at over 600 kilometers per second in one specific direction, towards something we can't even see. Astronomers call it the Great Attractor. It sounds like a sci-fi villain, but it's a very real, very strange feature of our universe. And the deeper they look, the more the monster dissolves into something even more unsettling, an invisible architecture of motion shaping where entire galaxies go. Let's rewind to how this mystery even showed up. If you look at the universe on the largest scales, galaxies are supposed to follow a pretty simple rule. The farther away they are, the faster they move away from us, thanks to cosmic expansion. That's the Hubble flow. Space itself is stretching, carrying galaxies along like raisins in rising bread dough. In that picture, there's no special direction, no preferred drift. Everything just recedes. But when astronomers started making precise measurements in the late 20th century, something didn't line up. They measured the cosmic microwave background, the faint afterglow of the Big Bang, and noticed a pattern. One side of the sky looked slightly hotter, the other slightly colder. That dipole pattern meant one thing. We are moving fast, relative to the cosmic rest frame. Run the numbers, and you get a speed of over 600 kilometers per second. Not just Earth, not just the Sun, but the entire local group of galaxies, Milky Way, Andromeda, and our neighbors, plunging through space in a single coherent direction. The question wasn't, are we moving? The question became, what is pulling us? Astronomers already knew galaxies don't just sit passively in the Hubble flow. They have what are called peculiar velocities, extra motion on top of expansion caused by gravity. Clock how far away a galaxy is, subtract the part you expect from cosmic expansion, and whatever motion is left is due to gravitational tugs from nearby mass. So scientists started mapping these peculiar velocities across our region of the universe. That's when the anomaly popped out. Hundreds of galaxies spread over a huge volume of space were all streaming toward the same patch of sky, roughly in the direction of the constellations Hydra and Centaurus. It was as if something enormous was dragging our entire neighborhood in its direction. They gave this unseen mass a name with serious drama: the Great Attractor. Early estimates made it sound monstrous, tens of millions of light years away, a mass equivalent to tens of quadrillions of suns, big enough to bend the motion of whole galaxy clusters. For a while, it really did sound like there was some gigantic hidden object waiting out there, pulling us in. There was just one huge problem. We couldn't see it. The region where the Great Attractor seemed to live lies right behind the dense plane of our own galaxy. Astronomers call it the zone of avoidance, because historically, telescopes just avoided it. Thick bands of gas, dust, and stars crisscross our view in that direction, blocking visible light and hiding whatever lies behind. If you were trying to spot a lighthouse from shore, this would be like staring straight into a stadium floodlight blinding you from anything in the distance. But astronomers really hate blind spots, so they started attacking that zone from every angle they could. Instead of relying only on visible light, they turned to radio telescopes that can see the 21-centimeter glow of hydrogen gas, and infrared surveys that slip through dust where optical light gets completely smothered. They even used X-ray observatories to pick up the blazing hot gas trapped inside massive galaxy clusters. When those different views were stacked together, the empty regions started filling in with real structure. Entire galaxies popped out that had been invisible before. Streams of galaxies lined up into filaments. Clusters like Norma suddenly weren't just coordinates on a chart. They were bright knots in a hidden web. It was like slowly turning up the contrast on a washed-out image and realizing there was a whole mountain range behind the glare of your own headlights. The Great Attractor didn't look like a single dot. It looked like a crowded, tangled neighborhood of galaxies and dark matter we'd been staring past for decades. So for years, the Great Attractor was a pure inference, an invisible mass revealed only through how it pushed and pulled other galaxies. No direct image, no obvious glowing cluster, just the motion. Then the hunt widened. Instead of just using visible light, astronomers turned to radio, infrared, and X-ray surveys, wavelengths that can pierce some of that dust. Slowly, the blank patch of sky began to fill in. Behind the Milky Way, they found something big. The Norma Cluster, a massive gathering of galaxies, also known as Abell 3627, sitting almost exactly where the Great Attractor had been predicted. For a moment, it felt like the monster finally had a face. Here was a huge, dense cluster in the right place, with the right kind of mass to tug on our region. But when scientists crunched the numbers carefully, they hit another surprise. Norma was huge, but not huge enough. It simply didn't have the mass to fully explain the 600+ kilometers per second motion of our local group. So the story had to change. What if the Great Attractor wasn't a single thing at all? What if it was a pattern, a whole landscape of mass rather than one giant mountain? As galaxy surveys improved, that's exactly what emerged. The region resolved into a complex web. Clusters, filaments, walls of galaxies. The Hydra Centaurus supercluster, the Norma cluster, other structures all connected in a giant overdense region. The monster stopped looking like a single beast and started looking like a whole mountain range. And landscapes don't pull from a single point. They shape flows. Here's where another key piece of the puzzle enters. Voids. We tend to think of gravity as pure attraction. Mass pulls on mass. But there's another side to the story. Cosmic voids are huge regions of space with relatively little matter. They don't literally push, but because they have less mass, matter flows away from them and toward denser regions, just like water flows away from high ground and into valleys. Our local group isn't just falling toward something dense, it's also moving away from something empty. On one side, we have massive structures like Hydra Centaurus and Norma. On another side, we have the local void, a big underdense region. Our motion is a combination of being pulled and being pushed in a gravitational sense, sliding downhill into denser territory and away from the high, empty plateau. This is where the Great Attractor stops being a simple answer and turns into part of an equation. Our velocity can be broken into components: contribution from nearby clusters, contribution from underdense voids, and contributions from even larger scale structures farther out. The single arrow of motion fractures into multiple arrows added together. Then the scale expanded again. Beyond the Hydra Centaurus region lies an even more massive concentration of galaxies, the Shapley supercluster. This thing is ridiculous, one of the most massive structures in our cosmic neighborhood, stuffed with galaxy clusters. Some flow studies suggested Shapley might actually be a major, maybe even dominant source of our motion on larger scales. Suddenly, the Great Attractor stopped being an endpoint and became a waypoint. Zoom in, and you see local flows converging toward things like the Virgo cluster. Zoom out a bit, and flows point into Hydra Centaurus and the old Great Attractor region. Zoom further still, and you see influence from Shapley dragging whole regions in its direction. The center of our motion depends on the scale you look at. Change the smoothing lens, and the attractor relocates. At this point, astronomers realized that counting galaxies alone wasn't enough. They needed a more dynamic map. That's where the idea of Laniakea came in, a reimagining of our cosmic address. Instead of defining structures only by where galaxies are, researchers started mapping where galaxies are going. They compiled catalogs of peculiar velocities, distances and motions for tens of thousands of galaxies, and reconstructed the underlying gravitational field. What they found was stunning. Our Milky Way belongs to a massive basin of attraction, a kind of cosmic watershed they named Laniakea, meaning immense heaven. It's not a single solid object like a cluster you could point to. It's a region of space where galaxy flows all converge, bordered by regions where flows diverge toward other basins. Think about how water behaves on a continent. Rain that falls on one side of a mountain range ends up in one watershed, flowing through rivers into a certain ocean. Rain on the other side may travel an entirely different path. In cosmology, galaxies are like water droplets, flowing along filaments into gravitational basins. Voids are the high ground. Superclusters are the basins. Laniakea is our basin, and what we used to call the Great Attractor is part of its central lowland, not the whole map. One of the coolest things about that Laniakea map is that it doesn't just draw where galaxies are frozen in place. It draws where they're going, like arrows on a weather chart. Some arrows curve gently, some plunge straight inward, but almost all of them within this region bend toward the same general basin. Cross an invisible boundary, and those arrows flip, pointing toward a different attractor belonging to another supercluster. In that sense, Laniakea is less like a single object and more like a traffic system for galaxies. And we're just one little car in that traffic. The Milky Way's path through Laniakea tells us more about our long-term environment than any single snapshot. It says we live in a part of the universe that's still dynamically evolving, still funneling matter inward along cosmic highways. The Great Attractor name sticks because it's catchy. But the real revelation is that we finally see the bigger interstate network it sits on, instead of blaming everything on one mysterious exit ramp. Then came another twist. Modern, highly detailed simulations, digital twins of our local universe, started revisiting the classic Great Attractor idea. They used real data as boundary conditions and evolved the system under gravity to see what kind of motion you'd expect. The conclusion? The classic Great Attractor, defined as a single dominant mass within a certain distance, doesn't fully account for either the magnitude or the exact direction of our motion. No single cluster, no single supercluster, not even Shapley alone can be crowned the one true culprit. Instead, our 600+ kilometers per second drift appears to be the vector sum of multiple influences. Evacuation from local voids, intermediate scale attraction from the Hydra Centaurus region, and long-range tidal pulls from even larger structures. The Great Attractor was never a solitary beast. It was a pattern emerging from incomplete data. And yet, the motion itself is very real. The cosmic microwave background dipole is real. The streaming flows of galaxies are real. What changed wasn't the universe. It was our map. Each new survey, each new catalog, each new way of looking at hidden regions like the zone of avoidance redraws the terrain. The name Great Attractor stuck, but the meaning evolved. So, what does this actually mean for us? Are we on a collision course with anything? Are we going to be swallowed by some massive structure? On human timescales, absolutely nothing dramatic happens. Even on cosmic timescales, the picture is more subtle than we're falling into a monster. Gravity is pulling our local group towards certain regions, yes, but the expansion of the universe, driven by dark energy, is stretching space itself at the same time. On small to intermediate scales, gravity still organizes matter into galaxies, clusters, and basins like Laniakea. On very large scales, expansion wins, and distant structures drift beyond each other's reach. In some simulations, our local group's long-term motion trends toward the Virgo cluster in the center of our basin. In others, when you include larger-scale tides and the evolving influence of dark energy, the future trajectory becomes more complicated. Every time we widen the map, include more mass, more volume, more structure, the final destination shifts. That's the humbling part. The universe isn't rearranging itself. Our understanding is. What started as something is pulling us turned into a whole new field. Cosmography, the mapping of our cosmic environment not just in static snapshots, but in terms of flows and motion. The Great Attractor was the first crack in the illusion that the universe is simple and symmetric. It forced us to admit there is hidden structure shaping where everything goes. Here's a way to bring it home. You, right now, feel stationary. But in reality, you're spinning with Earth, orbiting the Sun, circling the galactic center, and on top of all that, riding along with the Milky Way as it surfs the gravitational currents of Laniakea. The Great Attractor is our first hint that those currents aren't random. They're organized by a vast, invisible landscape of mass and voids, spread across hundreds of millions of light years. So what is pulling our galaxy? There's no single clean answer wrapped in one object. It's a layered story. Dense clusters like Norma and Hydra Centaurus, massive superclusters like Shapley, vast underdense voids, all woven together in a web of dark matter and galaxies. Where the flows converge, we've slapped the label Great Attractor. But the real attraction is the architecture behind it. The way gravity sculpts motion on scales our brains were never meant to handle. And we're still not done. New telescopes, deeper all-sky surveys, better peculiar velocity maps, they're all chipping away at the blind spots, especially in that zone of avoidance. Each updated map might tweak our understanding of where exactly we're headed and why. The monster at the edge of the map is gone. In its place, we have a living, evolving picture of a universe that isn't just expanding, it's flowing. Next time you step outside at night and stare at the stars, remember, you're not just looking out into space, you're looking downstream. You, the sun, the Milky Way, and entire clusters of galaxies are all riding the same invisible current, drawn toward a gravitational landscape that we're only just beginning to chart. If you enjoyed this dive into the Great Attractor mystery and the hidden flows shaping our cosmic journey, make sure to hit that like button. It really helps this kind of content reach more curious minds. Subscribe if you want more cinematic deep dives into black holes, cosmic webs, and the strange physics steering our universe. And tell me in the comments, which space mystery should we unravel next? Thanks for watching, and remember, you're never really standing still.